Hello, this is our ECP2 from Irfan, Malik, and Erik Tejada. It's a sound pressure monitor, and basically we have a bunch of components including a TLC 272 op amp, a few capacitors including a 4.7 microfarad, 15 picofarad, a lot of resistors such as a 10K resistor and also a variable resistor, which is right here. It's a 500 variable resistor. Basically, it's used to control the sensitivity of the circuit. So when we when we add more resistance, it creates a larger voltage drop, and therefore allowing less voltage to go to the ammeter and having less output. We also have, this is the ammeter we have connected right here between these two, resistor and capacitor, and that's the op amp right there. Also, there's a few diodes in there. Those are used to control the current going in one direction to where the ammeter is, to measure the current. And then we have...
Alright, there are two op amps in this circuit, and the first op amp is just an op amp with varying inputs, and the inverting input is connected to the output, and the feedback loop has a resistor and a capacitor in parallel. The non-inverting is coming from the 9-volt circuit input, but is dropped by multiple resistors before it gets to the op amp, and the output goes to the diode array and ammeter. The second input, or the second op amp, the inverting input is coming from the diode array and ammeter, and the non-inverting input is connected to the first, or the non-inverting input of the first op amp.
Okay, so now we'll just do a test of our circuit. We'll apply some sound and review the output on the ammeter.
Hello. Hello.
So there we saw we were getting about 300 microamps, which translates to about 30 or 40 decibels. Although regular speaking sound does get is around 60 to 70 decibels, we can attribute maybe the loss of decibels to the weakness of our